Welcome to Chapter 8, Composite Data Type. Composite Data Type. In this chapter, we will be covering the composite data type. What is composite data type? We have primitive data type such as integer, float, but that's only a memory location. But here we talk about composite data type, that is actually a collection of data that can be homogeneous, like all integers, or can be mixed format for integer, and maybe byte, and maybe character, and maybe floating point. We can have a composite data type of homogeneous type like array or string. We can have the composite data type of heterogeneous data type. And we may have data type that share the memory location like union. And we may have composite data type, but more abstract. We call it abstract data type for set, dictionary, pointer, and maybe list, and bigger data type like file operations. So in this chapter, we actually talk about these different composite data type. And this video may be divided into a couple of sections. So first, let's look at the abstract data type. We have data structure, and the data structure is the organization of data. We have linear data type, such as array, linked list, stack, and queue. Queue is first in, first out. Stack is first in, last out. And linked list array can implement both of these. And we also have nonlinear data types such as tree, graph, table, or sets. And actually, linked list can also support some of them. ADT, abstract data type. This can also be not known as derived data type. And some language may mention it as a reference data type. And we have stack, queue, set, and map. And some language call it collections, data collections, such as in Java or Python. And here are more detailed types of abstract data type, more advanced one. So usually array and string, basic queue and stack, we call it a basic abstract data type. And here this can be more advanced data type, more advanced abstract data type. And these data types actually are more conceptual and may have different organization and may have different implementation. In C language, we have fundamental data type, integer, double, float, character, and then we have derived data type, such as array and pointer, and we have user-defined data type, that is structure and union. And then these different data structures, data types can be used to implement all of the ADT we mentioned in the previous page. And this is for C language. But C language itself don't have object. For C++ data type is actually include all the data type that is available in C language. And we have the fundamental data type or atomic data type, like C language. And then we have derived data type and array, pointers, functions. These are C type and constants. And reference is a new data type for C double plus. And class is also C double plus new type. And the structure, enumeration, and union, these are also available for C language. And basically, C double plus language also support all the ADT that we mentioned before. JavaScript and Python, these are scripting language. And scripting language, we mentioned it has more dynamic scope type language. And actually it has more different data structure. But in JavaScript, we have object, we have Boolean, we have number, string. So the data type is very simple. And same thing for Python. It also has similar string and numbers. And then very basic tuple set, list, and dictionary. And we know that tuple is in parentheses in Python. These are using bracket. Set are using curly brace. Dictionary are using curly brace with column. And this notation is very similar to the object type in JavaScript. So dictionary and object in JavaScript are very similar, especially for JSON data structure. And these are more conceptual data type in these two languages, and primitive data type, they have fewer types. And for Java, it's more like C-like language. So it has the primitive data type. It has composite data type, and composite, you have the class array and interface and enum. The enum is very rarely used. And then string is considered another data type, but it's actually a subtype for class. And then these are for Java. This one is the Ada language. Ada language comparatively has more complicated data type. It has more data type for scalar, and it's more complicated. And then other than that is similar to Pascal, but it also has a complete data type of special task protected, and maybe actually has quite unique data type like task. Now let's look at the first abstract data type, structure or record, and the second one called variant or union. And variant or union are using shared memory location, and record structure are actually a collection of heterogeneous data type. Record structure usually laid out contiguously, possibly holds for alignment reasons because it's of heterogeneous data type, so you can have uniform layout for the memory location. A smart compiler may rearrange field to minimize the hole. C compilers promise not to, but some C++ may be. That actually depends on the compiler design. Implementation problems are caused by record containing dynamic arrays. And we won't go into that much detail, but we try to cover the basic concept for records and the implementation. And union are different. Union actually also accept the heterogeneous data type, but the memory are overlapped. Is overlapped space for different interpretation of the data format. and then may cause problem for type checking. And it's lack of text, so you don't know what is there. And actually, the ability to change text and then access field are hardly better, can make field uninitialized when text is changed, and require assignment of entire variant, such as ADA. So these are different, these are the variants. So here, let's look at the structure. In C language, we have such declaration. And remember that this structure element, this one actually is a type. And then here we have the detailed implementation for that. And passcode, we have a type declaration, and that actually this is a record. So in this record, we have name, atomic number, atomic weight, and metallic. So basically, it's a element, say maybe carbon, and you have atomic number. Say you have 6, and then you have, I'm sorry, wait, it's 12 or 6. I don't remember that. Sorry. It looks like it's actually 12. And then the weight. Oh, maybe atomic number is 6 and weight is 12. Okay, anyway, I'm not really sure of the atomic number for carbon now. I forget it. But actually, this is similar data structure for Pascal and C. Accessing the data field. For each data field, you have different way of accessing the fields. So, for example, we have an element, copper, that's of the type, structure type. Then here we have this Avogadro number for chemistry. That is actually a constant double. That's a 6.022 times 10 to the power 23 for 1 mole. Okay. And then we have copper that named 0 as C. The name 1 is U. Copper's number 1 is U. So basically you have Cu as a string for the name, as copper's name, and the mass is atom number is mass times the weight times this An, Avogadro numbers. That's your weight, atomic weight. So basically, your total weight times the Avogadro number, and then times atomic weight covers a single atomic weight. This one could be very light. So here is a syntax for record, or we call it a structure. So here we have an OR. OR is actually on top of the element. So here we have the element yielded, and then the name of the OR. OR is where we can get copper or something. Here we can have this. So here, as I mentioned, structure element is a type. So basically, this type is the same with the previous slice that we see. It's the same with this type. So this is a type. So I actually declare that type into my record over here. So basically, this one is a structure. This one is a structure without a type name, But here, this one is the data field name. So the data field name is the same with the way you write here. And this one is calling the structure, and this one doesn't call the structure. It's a anonymous type over here. But the two are the same. You have a character of 30 character for the OR name, and then you have the element yield for the OR. And that element yield are of the structure element type or this anonymous data type. So it's actually a nested data type. So here, let's look at the structure element type. It has a name of 2 characters, so that's 16-bit. So because that is 16-bit, we have integer atomic number. That atomic number actually is 32-bit for integer. And then we have double. Double need to have 64-bit. And then it's a Boolean metallic. So that's only 8 bits. So that's what we have here, and the layout and its impact structure. The field of the record are usually stored in adjacent locations. So right here is adjacent location. And in any array of the element, most compiler devoted 20 bytes to every member of the array. So basically we have, this is 4 bytes, 1, 2, 3, 4, 5. So that's actually dedicated 20 bytes. But apparently you have 3 bytes over here, 2 bytes over there, 5 bytes totally wasted. But most compiler would have take the waste, and just linearly lay out the different data type. It doesn't have the compaction. But this one actually, for the type definition for C++, one of the particularity of the C-type system is a structured tag. And it's not exactly type name. And here we can have a type defined structure. So this one is different. This song is a type name because we have a type defined. So basically, it's actually a struct this, whatever inside here. This is the type, and we define this type define. We define this type as the text song over here. The song is defined as this type. Song is defined as this type, the structure type. So we use this name to declare element yield and the second structure in 3.8.3. To obtain one word name, we can use type define, element, structure defined, and then element T. So this actually is mentioning this structure element is the type, and this type assigned as a new name the element T. And the element T actually represents structure element. Or even structure type define element struct tag. And something like this. You can keep the element as this name as well. And this should be a semicolon. And structure tag and the type defined name tag has separate namespace. So the same name can be used in each. C++ eliminate this idiosyncrasy by allowing structure tag to be used. So basically in C++, the structure tag itself is a type name. So in C++, whatever you write as structure A something, this itself is a type. It's different from the C. So this actually is easier. So you perform type define implicitly. So that's a little bit better. So nested record as value. So right here on the left hand side we have type T, types S, and then we have this structure like this. We have I and J integer type, and then structure type S. S has a type T. So this right hand side memory actually is of S type. The S type has an integer I, and then there's a type T over here, the type T over here, and then that is the data type. So we declare a structure S1, S2, and then S1.n.j, S1.n.j, you get to this field, you set it to be 0. And then S2 equals S1, S2 equals S1, and then S2.n.j equals 7. So we print it, it will print 7 for this one, because you share the same location. It actually copied to later. I'm sorry. This actually is construct the data field. It's a copying over here. So actually, you set this one, the S1 is separate. It's not the same. But this one actually, you have Java. Java actually, when you assign S1 to S2, S1 is a reference to pointing to a certain data, certain S type. S2 actually is S1.n is a T, so there's an n field that is for T object over here. S2.n.j is set to 7. And here your S2 actually accepting the reference from Java, so actually S2 also pointed to here. So this one it will print 7. And that one, it will still get 0. So here is the C language. Here is the Java language. So the way they declare it and then the way they store data are different. So this one actually just provide reference to there. They don't have the shared data structure. And when you declare the structure, actually these are two different structures of the same type. So the data are not shared. But this one is a reference type. So for Java, so Java's S2 actually pointing to the same object structure as object as the S1. So they share the data. So these two actually for C and Java, they print out different things. Record structure, layout or pack type. In Ada, we have a pack name. So a few languages allow programmer to specify the record to be packed. And when you pack, actually there's an optimizer. The Ada syntax is built into the language. So GCC syntax is a GNU extension. The directive asks the compiler to optimize for space instead of speed. So you can actually declare that the pack that, and then the memory will be optimized. But the address calculation will be more complicated if you have the address to be optimized. If you have your memory location to be optimized, your memory will be optimized, but you will spend more time to access the different data fields. So that's, for example, you can pack your elements in such a way. So basically, you kind of totally have 4 times 4 is usually 16 bytes. But here you have 1 missing, so actually totally you have 15 bytes to store the same record. And as we know that the previous one in C language actually end up with 20 bytes, and there are 5 bytes wasted. So pack one actually will perform maybe a little bit slower because you when you calculate the edges, it take more time. But in terms of memory size, it will be actually smaller. So structure, assignment, and comparison. Most language allow value to be assigned to the entire record. So this is actually a copying of the data field from copper to my element. So ADA allow records to be compared for equality. Most other languages like C family support those C++ allow programmer to define later for individual record type. So assignment but not equality test. For small record, both copy and comparison can be performed inline on a field-by-field basis. For longer record, we save significantly on code space by deferring to library routines. So block copy routine can take source edges and destination edges and length as argument. But analog block compare routine will fail on record with different data in the whole. So there's a block copy and there is a block compare routine that actually will help you to do copy or compare. And remember that if there is some hole, the compare may fail. One solution to arrange that all hole to contain in some predictable way, but this requires code to be every elaboration point. Elaboration point actually is where you declare the data. For this word, it's actually declaration. Elaboration means that declares. Well, where you declare, you can actually predict your data and the code. And another is to have compiler generally optimize, customize the field by field comparison routine for every record. So that actually will help when the memory is optimized. Different routine will be called to compare records of different type. Packing enumerate the whole but may be costly because this copy and compile and compare may take more time for a packed data field. So basically, with one single assignment, for many languages it allow you to do copying, and then for many languages they may have different routine to help you to do copy and compare. And those copy or compare function, when they implement it, may be costly because each record type may have to be optimized in different way. And some languages like Java, they all be a reference type. Record structure and variance. So a compromise to start record field according to the size of their arrangement. So basically, some way you can optimize in different way, like the right-hand side 8.4. Now rearrange the record field to minimize the hole. So instead of allowing the data to be out of shape, we try to optimize the record by moving the metallic up to here. Original is over here. And then you actually eliminate hole and then eliminate the HR4 by over here. So by sorting the field according to the size of their alignment constraint, the compiler can minimize the space devoted to the hole, and thus you can have the optimization and also maybe get an easier way to access the data. So that actually all type alignment field may come first, allowing by half word field, word aligned field, and the double word field. So basically you kind of using the smaller one in the front and then moving the bigger one. Because bigger one usually you have one integer or two integer space, like 4 byte or 8 byte space. They are easy to be aligned. And those the smaller one actually for single byte or 2 byte, they create more hole. Because in language in a computer of 32-bit architecture, ASI, each time you pass actually will fetch a integer size that's 4 byte size. So that actually also depends on the computer you work on. 64-bit, each time you will access the bus for 64-bit, then the size of the record and how you optimize it will have a different way of optimizing it. So this issue for memory optimization actually is also related to the machine you work on. Variant, union. Union is different from the structure. So the union, the overall size of this union will be the largest member because it's shared. And these three type actually they are shared data field. So double may be the longest one. I give you 8 bytes. So actually every memory, this memory that's 8 bytes shared by three data type, and they actually interpret it in different way. So that's for union. So union may have been used for man-to-man reason. Union allow the same set of bytes to be interpreted in different way at different time in the system. So non-converting type cards can be used to implement heap management. Byte bits are not being interpreted; they being used for independent purpose. So representing alternative set of field without a record. So actually, usually you kind of using the union for different interpretation. So traditional C union will occur when used for this purpose. A much cleaner syntax appear in the variant record of Pascal and its successors, which allow the programmer to specify field within a record should overlap in memory or not. Similar functionality was added to C11 or C++11 in form of anonymous union. But to me personally, I actually right now because the memory is not that expensive, so I really do not strongly suggest for the union unless that you really have something you need to interpret in different way. So here we have a structured union type for copper, that's a longer form. We have the data field that we introduced before, and here we have more different data fields. So these are the original one, and then here we have some new one, and the union is a extra fields, and then we have the natural occurring Boolean flag. And the union actually, this structure, natural information, and the lifetime actually share the memory. So here we have a structure and a double. So the longest one actually is this structure type. And the lifetime actually is just 8 byte. So the union will decide on this 9-byte format. So the union here Unlike the memory layout for element variant, the value of natural occurring field would have a true or false over there. And then you have a lifetime and what's that? Lifetime and record. That is natural info. Okay, natural info and the lifetime, they share the memory, but they have different lengths. So there's a double border. So unlike memory layout for element variants, the value of the natural occurring field is intended to indicate which of the interpretation of the remaining field. So this one is used. If it is true, that's the natural information, we use the field. And if false, we use the lifetime. So that flag is used to determine how long the record with union is. Arrays, definition for arrays. Arrays is very simple. Array are the most common and important composite data type. It has the homogeneous data type. So all the elements in the array are the same type. And structure variant, may have different type. So semantically, they can be sort of a mapping from a index to component or element type. So it's just like some sort of table, some sort of table lookup for functions. So a slice or a section in the rectangular portion of an array is shown later in 8.5. So here we have different data type. We have associative arrays, and that can be of the associative memory, a Python's dictionary. We have hash map, we have hash table, or SQL table. These are more advanced extension for array. That's called associative array. And also we may have the sparse matrix that is constructed by array and nodes. These are some extension for arrays. 1D, 2D, and then this is sparse and associative arrays. Array declaration in C language, we have the type and then array name and the number of element right here. For Fortran, it's like this, has a dimension 1 to 26, and Fortran is of starting the index from 1. So basically, that's the way you declare Fortran, declare array in Fortran. And then you have the character 26 element. You have ADA, you write down as this. Index in C language, lower bound of the index range is 0. You start from 0 to n minus 1 for n element. For Fortran, the lower bound for the index range is 1 by default. But of course, you can change. Multi-dimensional array. ADA, you have declare like this. Fortran, you declare like this. That's 2-dimension 10 by 10 magic. For modular 3, you declare by this, ADA by this. So array of arrays in C++, Java, or C#, they use the array of array concept. So every row of the metric itself is another array. So in declaration, you put 2 pair of the bracket and in front of the metric name. And then you can put like this, you can declare like this. That means that you have a check array that is array of 5, an array of 5 element of the arrays reference. And actually, you can instantiate like this, or you can instantiate like this. So if you instantiate like this, each row may or may not have the same of the same length. The length can be changed later. Array 2, arrays in C family. So here is the array principle. If we have type T and then we have array name A of n element, so basically we declare like this: an array of data type T and less n. We have the contiguous allocated region of n by size of T. So depending on the type of T, we will declare something like this. So we have a character of 12 element. We start the ages x and then the n and then the x plus 12. So each character we have 1 byte. And then integer we have 4 bytes. It will be something like this, double 8 bytes. And the pointer we actually depend on the 32-bit architecture or 64-bit architecture. 32-bit architecture we have 3 pointers, then we have each one have 4 byte addressing. And 64-bit we have the 64-bit 8 bytes addressing. So that depends on the machine as well. Basic principle, we declare this like this, and this we have this. And then the reference data type, we can have these different type, and then the value. So here we have the type reference, we have the integer type, and then we have the value like this. So if we declare integer value 5 element array like this, value of the 4, we would have the fourth element 0, 1, 2, 3, 4. We got 5. We have value that actually is a pointer. It will store the ages x. Value plus 1, we jump to this x plus 4. Here is the calculation for pointer. So each advancement for the val, it actually is a pointer. It will be increased by 4 because the type of integer is actually 4. It's a 4 bytes. And then we have the value of element of 2, that's this one. The address of it is actually x plus 8. And then value of 5 is out of bounds, so we don't know, but it's well in C language the overflow allowed. So there's no index out of bound issue in C language. And then if we have val plus 1, that actually is x plus 4. Body, we have this star, we call it the body of the data, you will get 8. And then val plus I is any number, so it actually depends on the displacement. It's a pointer, and x plus 4i, each I will represent a integer. So we have, this is similar to, this one actually is similar, exactly similar to the ages of v of I. So here we have a example. We have zip. This should be the zip code or something for different schools. So C and U have 15213. U of Washington has 9A1A95. UC Berkeley has 94720. So these are, each one is a integer of 5 bytes array type. So when they press in memory, it will be something like this. But totally 5 by 420 bytes for each address. And then we can actually declare U of W like this, and then here is a function. You accept a zip code digit Z and the index of D, and you will eventually access a element. So the assembly code will be working like this. So right here, if we have the U of W3, we would calculate ages by UW starting from 36 and then 4 times I is 6 now. I'm sorry, I is 3 here, UW3. It will be calculated as 48, and from here we get 9, so this is guaranteed. And this one, because UW only have 5 elements and you actually have index 6, that will be overbound. But if you do the overbound, actually you will get this 4, but there's no guarantee. That means that depends on the compiler. -1, you will actually get this and get a value of 3. But again, it's not guaranteed. But if it's over plus CMU 15, actually 0, 1, 2, 3, 4, actually 15 is outside of here, you actually has no guarantee and you don't know what's the value. So C language has no boundary check-in, out of range behavior depends, no guarantee relative allocation of the different arrays. So is this an operator? Associative array in C++ is typically defined by overflow of the operator C brackets. C# like C++ provide extensive facility for operator overloading, but it does not use these facilities to support associative array. Instead, language provides special index ER mechanism, which is a unique syntax. So basically, you just remember that it's actually some operator you can override. And the bracket actually operate to calculate the address for you. So you actually can provide some sort of indexing by string, indexing by character type. If you are in C++, it can be overridden. So memory, okay, sorry. And this actually allow the associative array or like dictionary type operation in C++. So array, we have slice and array operation. Slice section is a rectangular portion of an array. Fortunately, and the single array slice operation assignment C provide extensive facility for slicing. So do many scripting language. So basically, you can use slicing to access part of the array or matrix. So it's available in Perl, Python, Ruby, R language, and C, Fortune 90. Array 3, call stack and heap. Arrays dimension bounds and allocation, size, scope, memory allocation. Global lifetime static shape, local lifetime static shape, and the local lifetime shape bounded at the elaboration time. Okay, what this is? If the shape of an array, shape actually is the size of array is known at the compile time. So if the shape of an array is known at the compile time, and if the array can exist throughout the execution of the program, then compiler can allocate space for this array in static global memory. So if you declare it's a static and it's a global lifetime, if the shape is of the array is known at the compile time, but the array should not exist throughout the execution, then this become a local. So static shape is a fixed shape that you know how large it is. You can declare in the global memory or local memory. But sometimes in the shape you don't know at compile time. So not actually local time, but you actually declare. You may have to do dynamic allocation. So lifetime and shape are common options for C for global lifetime, static shape, C's global and Pascal global. Local lifetime static shape, you have the locals. Local lifetime shape bounded at the elaboration as ADA local, and actually this one is not supported by C. Arbitrary lifetime shape bounded elaboration, that's a Java array, and not actually can be in the heap, and then they can be changed later. Arbitrary lifetime dynamic shape, we have this different language allow the size of the array to be changed at the execution time. So dot vector is a descriptor, or dot vector are used to hold shape information at runtime. So it's some sort of like polymorphic data, but we call it dot vector. A dot vector are required when array bounds are not known at the compile time. And dot vector is usually stored next to the pointer, so we can have a pointer and then we store some dot information called dot vector. Typically, a dot vector for an array of dynamic scope will contain the lower bound for each dimension of the size of every dimension. Upper bound are also need to support dynamics out of bounds checking. When bounds are known, the arithmetic can be done at the compiler. So if the boundary is known, we are actually better to do a calculation at the compile time. So here is the Java data format. We explained this before. So static data you put into the method area heap is actually for the object data, and stack for the local variables. And here is how heap is organized. If we have string, we put the data in heap. We put the reference in stack. And employee, you have a complex data type, you put another object in heap. Same thing, employee 2, they may point into the same object. And the array stack or allocation, we basically can have a local variable. That's in C language, you actually will declare n by n table. So a dynamic local array can format function square, multiply the metric by itself, and replace the original with the product. To do so, you need a scratch array of the same shape as the parameter. Note that the declaration empty both rely on the parameter n. So n you can decide the size n, and that actually take the space of that size. That's called what? That's called the scratch array of the same shape. So basically, you copy that in, and you have a temporary variable for t as temporary, and then you calculate it, and then you return that to m. So m got modified. This is for C language. And call frame. Each function has a call frame, and then we have dot vector, and we have the pointer to a certain m as your local variable. So there is a pointer that is a local variable. It points to the m. M is in the stack is a variable size of the frame for Ada. Or for C, we have a local variable. We actually determine the size at the runtime, and you can grow that for the local variable in the stack. And we need that dot vector to help. Heap allocation for C++, we actually have the stack heap. Stack store the reference, and heap store the objects. So they have the object in heap, and this actually, if you declare this in as a local variable, is stored in the heap stack. And if we use a new operator, new is actually similar to memory allocation, mallocate function, and it actually assign this object to the pointer p array. And here is another way to declare it, so we can have this my object as a pointer that actually point to my object, my class object, and my array actually pointing to such a array in the heap. So heap allocation is actually storing the dynamic data, and the new function is related to the memory allocate function. So array can arrange shape at an arbitrary time. It's called fully dynamic. Because change in size does not generally occur in FIFO order, stack allocation will suffice. Fully dynamic array must be allocated in the heap. Several languages such as Snowball, Icon, and the old scripting language allow string array of characters to change size after elaboration. And Java, C#, had a similar capability. But Java is immutable. You will create a new string for it. So the heap actually can change the shape and arbitrary time, or create new object to replace it. Depending on the language, Java cannot change the size, but it actually will be of different things. Okay, array number 4, layout and calculation. So actually, array you have the column major and row major. And column major actually you kind of line up your array, the column first and then row next. That's a column major. Row major is actually row first for the index and then column. So that depends on the language. And Fortran is the only language use column major. But in terms of traversal, you can have either way to do traversal. So this is row major. You actually line up your data in this way. And column major, you go up in this way. That's when you put into the memory location. An array, you have two layout strategy, column major or row majors. And you have a row pointer. It's an option in C language. Allow row to be put anywhere else. Nice to have for big arrays on a machine with segmentation problem. Avoid multiplication. So there are something you can do. And the calculation for the edges for this, actually you can have different way of storing your data in C language. For the string, you will have something like this. Or you can actually use the array of array to store something like this. So actually this is more efficient in terms of if the memory get bigger. It would be better because each one had variable size. But this one, it fixed as 10. You cannot extend, no extension. And this one more flexible. For smaller one can be packed into there as well. So in terms of declaration of the array of arrays or pointer of arrays, then you have different strategy. So here is the calculation for 3-dimension object. So basically you calculate the third dimension times the second dimension times the first dimension. You will be able to access a 3D arrays elements. So the equation is like this. You can check this equation by downloading the PDF file. You will know how to calculate the edges at the compiler. Basically, it's a number just by multiplication. So in assembly code, you can do this to calculate edges. String data type. String data type is defined in different way for different languages. So here we are going to discuss the string data type. String, in some language, string are really just array of characters, especially for C language. C language actually has no concept of string. For C language, there is only character array. So usually you either use character or you use pointer. That's the way you define character in. That's the way you define string in C language. And also, C language need to have a /0 that actually is the number 0, 1 byte as the terminator for the string. In other language, they are often special cased, given the flexibility like polymorphism or dynamic sizing that is not available in array. So other language like C++ or Java or Python, they are associated with methods. So this language has object-oriented type, so they actually modify the definition of strings. So it is easier to provide these things for strings than just array of characters. So in modern language, strings are defined as objects usually. String as array of character, that is in C language, and at the end, we actually need to have \0. But if you use the size of function, it is not included. So usually when you allocate the memory, you need to use something like this times the size in order to get the right estimation of how much area, memory area you need to reserve for the array of characters in C language. Other than that, it is similar to other language. You put each character of the string into 1 byte format. And actually, you can also use different lengths, but for C language, the ancient C language, each one is actually just 1 byte. Here is for the C language, and right here, it already be treated as object. So basically, you need to include the string class, and then you can, if you don't use the namespace std, you need to declare a string like this, and this is actually a constructor, and that is the name of the string. It's not a pointer, and it's actually a reference. And then you can also define a constant character pointer, this one, accepting the pointer from hello or advanced by 6. Either way is a pointer to an array of characters, but this actually is treated as a string. So in C++, you can have array of characters, you can have a pointer to characters, or you can have a string object, 3 different types that you can operate. And if you use the string constructor, you can actually use this, that actually initiate a reference, or you can have that reference pointing to hello, or you can have one single parameter, and that single parameter actually is this one constant string of character and the integer, and then integer means initialized to the first n elements in the CS. So actually you get this over there for a string, and then you actually number 4, you actually have first number and then h. That actually is create string initialized to nsc, and that is the number of the characters. So that actually is giving you actually something like this, 5 of the kind h characters. And then you can also have 2 pointers you initialize the string object to have the value of the range of the 2 pointers. That actually is a certain pointer, and then you start it to from B and then to the end of E. That is 2 pointer, your begin and end. So B means begin, E means end. So you can specify a certain section using 2 pointer from a original string to a new string. These are different constructor for C++ language for strings. String as object, and actually in Java language, string can be stored in heap, and you can store in the constant pool. When we store it in constant pool, something like this, we can call it intern, I-N-T-E-R-N-E-D, intern string. That is not stored in heap. That's actually stored in heap, but the variable itself will be put into the constant pool. That actually is a pool of the strings, and those can never be changed. And if you use the constructor string, you actually will store to different location. So Java language string model is different from C, C++. Those are more like arrays, and Java treat it as object. So it's kind of different. And it will follow the reference model for the object model for the object. We call it Java model, memory model. You need to follow the rules. So here we have Java string, that is object. C# is also object. CLR type is object object. That's the different language that support string as objects. Escape sequence. In string function, we have the escape sequence in order to handle some special characters, and it is listed down over here. Something to take note of is are these new line, new font field to change a page, and then backslash, double quote, single quote, Unicode, and hexadecimal numbers. And in some case, actually, these are just the same. And regular expression in strings. So here are the associated regular expression for strings. Right here, it is a set. This 013 is a set. So basically, you either has a 0, 1, or 3. So it actually is 1, 0, or 3 characters. Or you can use a range, or use kind of range. So here actually means 2 digits. And then here you have number, but not including 4, 5, 6, 7. So here you have the n, that's the intersection of the two sets. So basically, the intersection would be 0, 1, 2, 3, and then A9. And then this is lowercase character or a digit. And then this one upper lowercase or leading upper lowercase letters, and then follow with lower uppercase letters and digit and underline, or this is actually the dollar sign, and then star means 0 or more. So Here are the trading characters. And this one is WOB, leading by WOB, and then trailed by AD or EED. Okay, this one has a leading AG, CA, or CO. That could be a state, Arizona, California, or Colorado, and followed by two numbers. So these are the special definition of the regular expression in strings. And string in Java has these different functions. Set. Set is another data structure, but it actually is part of the ADT. Some language do support this data. For example, like Python, it has the setup. You can have A, B, C. These are the sets. Some language has a support. Some language like Java is not standard language data type. It's actually in the collections library. So in set, that's a discussed set for in Pascal. In Pascal, you have a certain range, a set of the range 1 to 10, or you can assign a set 1, 2, 3, 5, 7 to S, and then T as 1 to 6, and then something like that. And set operation equality, inequality, less than equal to, greater equal to. So this is subset or equal. And then no, you have intersection, union, and difference. Subset or equals actually is this includes sign. This is actually this one contains signs, and this one is, and this one actually is not equal to. Set, we learned about a lot about possible implementation. Usually set you can use a list or even array, you can implement it, but array is not the most convenient one. You can use a list, linked list, array list, those kind of different data structure to for sets. And you can actually also use the hash table or hash tree for sets, but that's not super convenient. And you have the following function. Sorry, you had a function of operation of intersect union membership can be implemented efficiently with piecewise logic instruction. Some language place limits on the size of set, make it easier for the implementator. And actually, this is not really important for the size now. You can always implement it to be more flexible. Computation time is not that much. For Python set, you can create a set of new, old, list, and new, and then you you can also use a list and then use a set function to convert a list to a set, or you can use the curly braces to include the set elements. And the set operation are quite many, as you can see right here. All of these are set operations. All of these are set operations, tons of different set operations. You can study that. The purpose of this chapter is not to introduce those functions. And set in Java actually is part of the collection. And set, you have the basic hash set, linked list set, and tree set. So hash set, you use hash table for implementation of the set, and then linked list, you actually link hash set, you use linked list to implement the set. Tree set, you use a tree, hash tree to implement set, and you have sorted set and unsorted set. So here are the different functions for your sets. And you can actually convert that set to an array. So here is using map to mimic set. So basically, when you use map, you had a key and value. Map in Java is similar to dictionary. In Python, you have the key and the value. And then you actually can set the value to be present or not present. And that is the way you can handle that as a set. So you can actually use this hash set. That's a hash set class. But I'm actually using the hash map to implement it. Pointer and recursive type, basic and reference model. So here we will start the pointers. So basic operation for pointer, reference, node, and recursive type. In C language, we actually we have the pointer. So this star sign usually I call it body or the object of a certain pointer. So this is called the reference. The reference of the pointer. You try to find the implementation or object or body of the variable. So right here, we have I equals 10, and then I assigned with J pointer assigned with I's edges. And then we find the body, and the body of the J actually is 10. We time by 2, so K become 20. So that's called the referencing of the J pointer. And at the bottom, we have year as a variable that's stored with the value 67. When we have an HS year, that actually is a reference variable, is pointing to 67. So this ampersand sign is also known as the variable in C++ is declaring year as a actually this ampersand sign in C++ language. I call it alias. It actually creates an alias or reference for a variable year. So it's the same name reference. So it's actually pointing to the same object as the variable. And the pointer actually is different. Pointer will have to store the ages for the variable. On the right hand side, we have a no value pointer. So a no will contain a value and a reference. So actually this is in C++ language. You have a structure. That structure node is a pointer. So you can use that to construct something like this. For example, you store 2000, that can be the agent for the next node. So it become a node for the linked list. In Java's node class, you can also have the value and node, but this node is not pointer. It actually is a reference. You can use that to construct some linked lists like this. So here are basically the main function. We create a node A, put the value to be 5, so we create this one. And then create a B node, set the value B, so it's something like this. And then B's null set null, but we assign B's A's next function pointing to B. And then we actually use while loop to print out every individual node. in the linked list. So Java language without pointer, but you can actually also set up linked list by using a reference as pointer. Pointer and recursive type. Pointers serve for two purposes: efficient access to the elaborated object. So it's actually declare object. Dynamic creation of linked data structure in conjunction with heap storage management, and that's very efficient, and that's why C language still be very much used as a good high-level language programming, but low-level actions close to machine code. Several languages like Pascal, Ada 83 restrict the pointer to accessing things in the heap. But C language, because it's a general pointer calculation scheme, so you can actually store any ages you like, even a pointer to a function. That's allowed. Pointers are used as with a value model of variables. They aren't needed with a reference model. So pointer is not reference. Pointer is a storage of ages. Syntax and operation. Operation of pointer including allocation, deallocation of object in the heap. That's main feature for C's or C++ use of heap, and that's dynamic memory allocation, and pointer make that using of the heap more efficiently. So the referencing of pointer to access object to which they point, and the assignment of one pointer to another. The behavior of these operations depend heavily on whether the language is functional or imperative. So the operations are actually depend on the memory model or reference model a lot. So here we have a comparison for different memory model. First, let's look at C language. C language, we have a pointer, and that pointer can receive the memory allocation of size of integer. Actually, that is only one integer. And then that return type is casted to integer pointer type and then assigned to P. So P actually is a address. So we can actually scan for P's location. You can scan something and put a 10 over there. And then you can print, but now because P is a pointer, so you actually need to print its body. Or you can print P's own address, but that's not the value 10. That's a P's address. That's C language. Right hand side you have Java, and Java actually you are really using the reference. That's all reference. That's not really pointers. C++, you have the class right here. You have class vector right here that can declare a different type of class and objects. So you can use reference like this, or you can use pointers. Either way, C++ support both pointer and references. And C# language right here is more like Java's case. You actually handle it like have the class and all of the reference variable without pointer, without the alias operator. They are actually more like a reference, more like Java's case. So it's actually more like Java's object model. So reference model, in ML family, the variance mechanism can be used to declare recursive type. So recursive type means actually more like the model that we use for the language, programming language. Like it's a little bit like the so-called uh, context-free grammar. So you actually can declare as empty or some tree like this. You have a right node, left node, and a tree branch. So you can implement a tree like this in ML language. So CHR tree is either empty leaf or a node consisting of a character and two child. So character of the tree or two child tree, and then there's a node. So you can declare like that. And then you put your R on the node of the characters, and then two child trees. So that's the way you construct. In OCaml, you can write something like this. Punch sign, it denotes a node, and then you have a node of empty for the X. So actually, this is one child. And then there's another child on the right hand side. You have node Y, and then node Z and node W. That's the syntax for OCaml. And then in this, you can have different way. And the punch backslash notation serves as the same purpose for surrounding quote in other language. So you declare a certain symbol in this language. Pointer and recursive data type. This per binary tree. So each one you have a leading car and care CDR. You can use that to access the leading node and the rest of the node. So you can implement a tree in this like this. Pointer and recursive type. Basically, pointer can and the link structure can be used to implement the recursive type, and the recursive type is more a higher level concept data type. In the compiler, for example, it is likely that simple table record and the simple tree node will need to refer to each other, and the syntax tree node that represent a subroutine call will need to refer to the simple table record that represent the subroutine. So here we talk about the tree structure, and actually also with some subroutine type that is a closure or a function call. So ML addresses this problem by allowing type declare together in the group. So OCaml syntax is the following. We have a type subroutine information, and then there's a call for the tree node. And then we have subroutine called information that defined as this. So here are different entries that support the syntax tree node. This actually, the syntax tree node is what we may talk about in chapter 4 and chapter 3, chapter 4. It is actually the node of that. And the tree node, you actually has a table and different information contained in the tree node. So that is actually syntax tree using OCaml language. Pointer and recursive. Type number 2, value model. Value model, tree type in Ada and C. Let's look at C first. C, you have a child tree, that's a node. And then there's a value and a left child and right child. That's easy to understand. And in Ada, you use the node declaration. Same thing, you have left, right child pointer and the value data field. And that becomes a structure, or you call it record in Ada. And then allocating heap node in Ada, you use a new operator. And in fact, for Java, for all different language, if you see the new operator, it usually just like memory allocation in C language. So use the structure's size. For here, actually, you have two pointers that's 4 bytes each in IS34, and then there's 1 byte, so totally 9 bytes for the structure tree node. And in C++, Java, C#, they all use a new operator in this language. That's actually similar to memory allocation or C allocation. So here again is the implementation of the using the pointer and the link structure to create a recursive data type. And recursive data type usually like tree type data structure. Pointer dereference. Dereference is actually use the star in C language, or a passcode you use the cap sign. And dereferencing is to find the body of it. So here, if you use the star, the pointer, it will point into a structure or object. But I prefer to write in this way using the pointer dash greater sign for the to access in the data field of a object that my pointer is pointing to. But you actually can find the body first. The body will have the record over there. Implicit dereferencing in Ada. On the assumption that example A.40 pointer almost refer to records, because records and pointer help each other. It is useful with the record to build different tree structure, or you use the so-called structure that help you to organize the tree structure or the linked list. So usually pointer are strongly involved with structure. Ada dispense the dereferencing together. The same dot-based syntax, that's the data accessing of the data field, can be used to access a field of the record full or the field pointed by full, depending on type of full. So right here we have a T is a tree, child tree, and P is a pointer. So T's value you can actually assign by a character. And P's value, P is a pointer. So this is the dereferencing in Ada. And you can use like for the entire body being assigned to T instead of just setting a single data field. So Ada's dereference structure is different from C, and it is more complicated. Java's reference type is pointer without implicit dereferences. So Java is the reference type is a pointer with restriction that we mentioned this before, and it actually is a pointer with implicit dereferencing. So Java's reference is different from C++ referencing. And here we build that linked list before, as we mentioned before. So in Java language, there is no such terminology as pointer, but I usually use pointer because the reference in Java is similar to the pointer in other language, but it only has some limitation. So using the same node as the previous lecture, head is a reference type to node. If toString is defined, to print head will print out the head's body's toString function to return value. If the toString is not defined, then hashcode will be printed. So head is a pointer. It stores the edges of the body or the object in a heap. And Java's pointer is the reference type. Pointer and the recursive type. Assignment in Lisp. The imperative feature of Lisp does not do not include the dereferencing operator, since every object has self-evident type, and the assignment is performed using a small set of built-in operators. So basically, it uses the setf or setcar or set star. Uh, car is actually called care rather than the most common assignment operator. For example, if full refer to a list, then car full actually means the right hand side, the rest of the list. And actually, in functional programming or grammar point of view, the rest of the list can represent the right hand side of a grammar, and the car is the first element that actually can be the leading uh, the non-terminator in the grammar tree. So this actually define the different way of setting car and cat CDR. C pointer and the array reference. And C pointer, if you have a one star, is similar to use A and bracket. Actually, that's an array. But this A itself actually is a pointer. So this is also equal. But be careful, the equivalence does not always hold. In some location, pointer is a pointer, array reference is array reference, and specifically declaration allocates an array. When you allocate some memory in the memory using the memory allocator, you will return a pointer type. And if it's not specifying the size for the first dimension, otherwise it allocate a pointer. So this and this are pointer to integer. And this is actually an element of the row pointer. So here n as n elements array of what? Of the pointer type. So an is a n element array, and that n element array body is integer. So all the array elements are pointers, and this is to the array. So compiler have to be able to tell the size of things to which you point to. So the following on be read. This is not good. This is fair. And C declaration rule: read write as far as you can, and then left, and then out a level and repeat. So what does that means? That is your understanding. So read to the right is an array. So that's an array element of what? Up to the it's a read write as far as you can. You reach to the end here, so it's an array, an element array. And then you read that you see a star. So this is an array of what? This array's body, each of them is actually an integer. So that's an element array of pointer to integer. And this one different. This one is read to the right. And here you will see it's a pointer A to an element of integers. So A itself is a pointer to what? To the n element array of integers. C pointer and array reference, we declare an integer and a pointer A, and then a array B. B has 10 integers, so we can assign B the address to A because A is a pointer. And then A's 3 will be equivalent to B's 3, will be assigned to N. And or you can use this. These two are actually equivalent. So pointer and array. Many C programs are actually use pointer instead of subscript to iterate over the element of array. So pointer is also and pointer and ages index are of the same thing. Before the development of modern optimizing compiler, pointer-based array traversal often served to eliminate redundant ages calculation. That is faster. Every time you just plus one. And thereby leading to faster code. With modern compiler, however, the opposite may be true. Redundant ages calculation can be identified as common sub-expressions, and certain other code improvements are easier for intercase than they are for pointers. So in chapter 16, pointer make it significant more difficult for the code improver to determine when two L values may be alias for one another. So basically, in C++, we have to care about more about alias. Stack smashing. Stack smashing, the lack of boundary, and the checking of the array subscript pointer arithmetic is a major source of bug. It is bug, but actually it is also a side effect that you can take advantage of. So many internet viruses propagate by means of stack smashing, a nasty form of buffer overflow attack. So Java actually doesn't allow this kind of index out of bound, but C, C++, because of the pointer, you can have the pointer to get outside of its data zone. You can still access data, and then stack smashing can be prevented by manually checking array boundary in C. So that's the problem with stack smashing. Dangling reference. Dangling reference and garbage collection are a pair of different objects. Two are related. So dangling references. What is dangling references? Dangling references are references that point to no object. That's so-called dangling references. So the problem with dangling pointer are due to the explicit allocation of heap object. So the object can be removed, but your reference or your pointer still be there. That's dangling references. And that on the other way, if the object has no reference pointing to, we call it garbage. So two implementation mechanisms are used to catch dangling pointers. One is tombstones, the other one is lock and keys. Here is a tombstone method. Tombstone, a valid pointer refer to a tombstone, and then a dangling reference refer to an expired tombstone. So here, basically, you knew a pointer and that new a object over there, and then you can assign the pointer to some other people. So pointing to the same tombstone, that pointing to a same object, and you can delete some pointer. So if you delete this, actually both of them are actually this is deleted, but your pointer won't be able to see anything, and pointer 2 is still alive, and it become a dangling reference. So with that, this tombstone, we can actually avoid the misuse of the pointers because of the dangling references. So solution is use tombstone. Tombstone, every heap dynamic variable include a extra cell called tombstone. The tombstone is a pointer to the heap dynamic variable. When the heap dynamic variable is allocated, the tombstone will be set to null. So in that case, this edge is set to null, you no longer pointing to any object. So the disadvantage is the memory and time, because you need to add the tombstone cells. Dereferencing. You can also use lock and key. Lock and key is a valid pointer container key that match the lock on the object. So each time you access the data, you have to check the lock and your key, make sure they actually access into the right object. But if you delete some cell, the key will be set to 0, so your key will no longer be able to access the object's location. So there's another way of doing things called lock and key. Pointer, instead of being an edges, and also have a key made into a pair. So heap dynamic variable also have a header contains a lock. When allocated, the key A and the clock are set at the same time. When allocated, they are set at the same time. So key equals. So you actually, when you allocate the memory, you set the key and lock to be the same value. So you can allow the access is granted only if the key and lock are matched. Otherwise, it's different. But when you did allocate, the lock is clear to be an illegal lock value. So you set that to be 0. So your key no longer be able to check the lock and can never go into the dynamic heap dynamic variables. Garbage collection, theory, and the reference counting. Reference counting is one way of handling garbage. So what is garbage? Garbage is unreferenced object, and dangling reference is a reference that has no object that it is pointing to. So two are opposite concepts. So you can create a new student SA and SB, and then you assign SB's value to SA. Then your object that original been referenced to by SA is now become a garbage. And this garbage actually will have to be handled. Otherwise, your memory will be a lot of garbage that is actually unused. So if we assign this local variable, a pointer variable, with a memory section of 127 byte, then because after you return that local variable have been done, but your heap already spent so much memory location for it, so that whole block become a garbage. So what is garbage? Garbage collection. So what is garbage collection? Garbage collection is finding garbage and reclaiming memory allocated to it. Why garbage collection? The heap space occupied by an unreferenced object can be recycled and made available for subsequent new objects. When is garbage collection process invoked? When the total memory allocated to a Java program exceeds some threshold, then you have to do garbage collection. So usually, a lot of languages have the garbage collection in the background, or it can be done by OS code or something. Is a running program affected by garbage collection? Of course, your program will be suspended and for a while, so your performance will drop. But the memory will be reclaimed. So the advantage of garbage collection eliminates the need for the programmer to deallocate memory block implicitly. So you can save time and actually that is safer, because if you don't have garbage collection, each time you try to not to use some memory block, you still need to write some program to take care of it, and that is a waste of time. And also, when the program get bigger, it is not easy to always being able to deallocate all the memory blocks. And garbage collection can dramatically simplify programs. So that's a good advantage for garbage collection. The disadvantage of garbage collection is garbage collection and overhead that affect program performance. Garbage collection requires extra memory. Programmers has less control over the scheduling of CPU times. Garbage collection issue with garbage collection mechanism design. Many languages leave it up to the programmer to design without garbage creation. Others arrange automatic garbage collection. And I do like garbage collection and with reference count. Reference count doesn't work for circular structures, and it works great for string or linear data structure. Should also work to collect unseeded tombstones. So here is a memory as graph. When you view memory as a directed graph, each block is a node in the graph. Each pointer is an edge in the graph. Locations are not in the heap that contain pointer into the heap that is called a root node. So we have a root node that is reachable. So we analyze from the root node and each one are pointing to some thing until that they are all marked. If some of them cannot be reached, we will be removed. So the node that is not reachable is garbage, then they can be removed. So here is one method to do reference counting. So as long as we keep track of the number of the reference, number of the count for reference for a certain variable, we know that when it drops to 0, then that object become a garbage. So we knew an integer of 57 and assign the piece address to Q. So both of them refer to it. So to reference. And then we can do this. And the left-hand side is a mutual inclusive access to make sure that the P and Q's reference number are set correctly. So for example, we knew a object 57 and set a pointer to P and send 99 to Q. It will be originally it will be set into the same different location, but later you assign Q to P. So when you do this assignment, you actually need to reduce the reference count for 57 and then add the reference for 99 by 1. So this is actually complicated and doesn't work that well. So reference counting model. Reference counting model will fail when you have circular structure, especially for circular queue. So garbage collection with reference count, but this one reference count will create trouble. But for example, here we have all of the reference set up, but actually the storage stooge actually is assigned with null. But because it is circular, so the object themselves also assume that it's all linked. But actually, even though it's a link, it actually is still a garbage. So with the reference count number not equal to 0, but it doesn't mean that these are not garbages. Actually, these still are garbage because they are totally lost. So reference count model actually doesn't work for circular structures. So the advantage conceptually simple for using this reference count, and garbage is easy to identify. But the problem is that you cannot work on those cyclic references, and there are some overhead. Garbage collection model 2, mark and sweep. So mark and sweep is also easy. It's commonplace in this dialect, and actually garbage collection is part of the feature for this dialect. And complicated in language which with rich type structure, but possible if language is strong type. So it achieved well by Java, C#, Scala, and Go. Complete solution impossible in languages that are not strong types. So the idea is to do positive marking. The collector walks through the heap, so we check every block, and then making every block as useless. And then begin with all pointers that's outside of the heap. So we check one by one to see which part can be accessed and which part cannot be accessed. And those cannot be accessed actually are marked as garbage and then take out and return back to the heap control, back to the program. So here is a mark and strip collecting. So each time you try to start from one pointer and then check every pointer to see if there are some nodes that never been accessed. So you will know that those are related to garbage. So assumption for a simple implementation, we have new, read, and write. And each block has a header word. In instruction used for garbage collection is pointer, length, and get roots. So the box and strip algorithm is like this. We get a pointer, check if the pointer is actually not empty. If not empty, then we return. If it is empty, and then we go into here, we mark set bit set to P, check if there is already some mark. If no, then we set the bit with that P pointer, and then you can mark all of the words in the P data structure. So if P is a pointer, we actually, if not a pointer, we return. If it's not a pointer, we guard against it. So sweep using length to find next block. You actually each time advance by block size. So pointer reversal, it can be used in mark phase to save time. So actually reversal will give you the similar concept of pointer reversal. So here we go through the whole tree of the garbage, and then we reverse the pointer, and by doing that we can actually mark the whole tree structure. So real world garbage collector, we have the Java memory model that have heap, and that has that heap also has this information tenured or permanent, and there's some of your heap with valid and invalid data. List. Now we are going to talk about list. A list is defined as a series of data of the same type or different type, and you actually may have homogeneous or heterogeneous data. You can have a integer, or can have a string or something. As long as it is in a list structure, and lists are ideally suited for programming in functional and logic language. So list itself is actually a abstract data type, ADT, and they are something to implement it by using linked list or array to implement the list. And in this, in fact, a program is a list and can extend itself at runtime by constructing a list and executing it. And the list can be used in imperative programs. And same thing in Python, list can be a data, can be a program, as long as you convert it to some proper function or something. So Python language is very similar to Lisp in fact, and it can also support the functional programming. So basically, list operation in Lisp, you have a const function that construct a list. So list cons means construct. You build a list, and it becomes something like this. Car function, you get the leading character or leading element. Car neo, you get nothing. And cat actually CDR. You get the now including the first one, you get the rest of the list. And append, you will append two lists together, and all of these functions are supported by Python now. So it's similar to Python's list. So functional programming in Lisp is completely replaced by Python. And in ML language, you have this to construct as a list, and then you have getting the head or getting the tail, and join function for the ML language like OCaml. So ML and Lisp, both ML and Lisp provide many additional list functions, including one that tests the list to see if it is empty, return the length of the list, reverse order of the list, search a list's element matching some predicates, or apply a function to every element, returning the result as a list. All of these actually right now your Python language can all do all these. And Python has more features as well. So this language become not as useful. And list comprehension, Miranda, Haskell, Python, F function, F sharp provide lists that resemble those of ML, but with important additional mechanism known as comprehension. Comprehension is something like this. Okay, something like this is called comprehension. So each element is similar to, I have a y, and each y actually equals I times I, and then I belong to the set of 1 to 100. Also, y modulo 2 equals, this I modulo 2 equals 1. It's R number, and then from 1 to 100, and then this is a set representation. So this comprehensive is a good constructor for a list. And the common form of comparison, expression, and enumerator and subfilter. This is very powerful, either in Python of F sharp or Haskell. This comprehension is very useful. And this functionality, actually some programming language like Java or like C, C++ don't have. That makes them not able to explore the functional programming as good as Python. Now, let's look at the file and input-output. Files and input-output. Input-output facility allow program to communicate with the outside world. So basically, the input-output facility, you have a program, and then you allow input and provide output. That actually can be interactive, or it can be a one-time deal. And interactive I/O means keyboard and your screen, something like that, with the human user or physical device. Files generally refer to offline storage implemented by the operation system, and file can further be categorized as temporary or persistent. So first, let's now take a look on the file permission. And this one is important. Actually, it's the access permission. You have read, write, and executive flag for the user group and others. These are first used in Unix and later adopted by Linux, and actually is one system. And if you have a D, means that is a directory, and nothing means a normal file, and sometimes you may have B as well as a binary stuff. Anyway, and you have ownership, the user ID, group ID, file size, and modification time, and the file name. And this is the file permission in Unix. And you sometimes you can change the permission role by changing mode, and you can specify them by the number. This one actually is 111, you get 7. And then if you have 000, you get 0. So actually this is a number from 0 to 7 for each of them. And you have the user group and other 3 access control for each file. And the layer of file system by abstraction, you have lower level, you have storage device, and then I/O control, and then basic file system, and then file organization module, logical file. So you actually access the file when you open the file. When you open the file, you actually, most of the time, you deal with the file handler. So you open certain file with file name. And the OS actually will work for you for file organization, basic file, and everything. And your file really, you access will be like here. And your application program will have to write something like this, and then you are accessing the logical file system. So basically, this is equivalent to this application. And then the file system you work on, maybe the inode or driver table is on I/O system. It's right here. And actually, it may be also including some of the file system here. And then you actually work on the I/O control, something it will be on this level. And then you have block and unblock devices that you need to handle. And that's the operation system aspect of the file system. So handling file in C language, you need to include stdio.h, and then you create a file handler or file pointer. That's a file handler, and then you let that using the file open, and the R is the read mode, and you can perform the I/O function such as file scan F formatted, file print formatted, file get string, file put string, file read, or file write. File read and file write are using for binary files, and others are used for text file. And usually this is actually used in block or byte situation now. In the past, you also had a bit string, and when you finish, you use the file close. And these different functions remain available for C++ language as well, as you include the write file module. So here, if you open, you can put in a file name, that's a string, and the mode. And you, for example, you file a text file in reading mode. And then if it's null, that means that your file opening operation is not successful. And W for write, A for append. So here are the mode. You can put R or RB. RB is the binary read mode. W is write and WB is write binary mode. And A is append and AB is binary file appending. And you can have R plus, that means that you can open file for update. You can read and plus write. And by B means binary. File processing, you can get string, put string, print, print, formatted print, and then file scan, formatted scan, and your character format. Here you can do a delete line. So you have open a file for reading mode, the other one for writing mode, and then you get it from file one with 100 byte each time, get a string, and then you actually can put that into file two as long as it's not a new file marked. So you actually scan through the buffer, and then you make sure that it's not the end of the file. Other than that, put back those string contents. That actually is a delete line, and then we actually delete all the all empty lines, and then you close those files. Binary file processing, you have fread and fwrite for buffer, size of the buffer, size of the each character, and size of buffer, and then the file call handler. So student one, you open the file for writing, and then right here you can scan from the file. With when you scan, actually you need to put an address for the variable because it need to be a pointer. So that's the pointer of the string student ID. Let me see, student ID is where is the student, right here. The student's name and student's year and student's major. Okay, that's in the struct. So here you have the here and then size of a structure. So the second one is the size of a structure. So that's the integer variable that you see over here. That's whenever you do a buffer, you try to read in or write out using the buffer. This size is the size of the integer or size of a character or size of a structure. And here are the number of the copy of the structure or buffers. So by this, you reading in everything, and that's ST is a structure with the student ID, student name, and student year, and student major. And this student major is a string. And in fact, this one you also need to have that @ sign to make it a pointer on yeah. So something like that. Student 2, you open the file for reading and binary mode. So this one you actually use fread. Each time, same thing, you read the size of the buffer, and then you put in something that is to print it. So you print out the data like this. Random access. Random access is you actually not following the order of the byte, and then you can randomly access a certain position in the file. So a file can be random access or sequential access. So you need to have the seek function, fseek function, And rewind is move your reading head to the starting of your file. And left tail function. All these functions are also available in Python. So your fseek, you have seeking for different position. You set the file start, current location, or end. Okay. And then this is an example for using the sequential access. I'm sorry, this one is only access a file that read in a lot of message, and then actually you use the rewind. You only use the rewind to reset the file, and then each time you kind of print out some words over there. So you actually print out the hello world, thank you very much, into a file. So basically here you insert a sentence to a file, and here's you put to the screen, and then you actually get words from the screen, and then you print that out, and you rewind the file. That will be appended. Namespace. Namespace is like a module. So basically in C++, you have a namespace. A namespace is like a module that we mentioned before. So namespace, a logical compartment used to avoid naming collision, and the naming collision or collision always occurs and may occurs. When some program is using more than one library with some variable, and each library has some variable may use top or maybe use name several times, and then you would have conflict. The name collision may occur for global variable, global function, and classes. Default namespace is the global namespace and can access global data and functions preceded by this specifier, domain specifier operator. We can create our own namespace, and anything declared within namespace has scope limited to the namespace. Creating a namespace. Creating a namespace is similar to creating a class, and this we discussed the difference between the class and namespace before. So namespace declaration appear only at a global scope. Namespace declaration can be nested, so you can have different level of the module. It can be put into another namespace. A namespace declaration don't have access specifier. No need to give semicolon after closing braces of definition of the namespace. We can split the definition of namespace over several units. So the syntax is you have the namespace and namespace name, and you put everything inside. That create a namespace, and that's a module. And you can actually use that namespace. And you may also have the unnamed namespace. Unnamed namespace are the replacement of static declaration of. So you create a domain, certain domain. It's a block level, and then you have locality or sharing space inside the unnamed space. They directly are usable in the same program and are used for declaring unique identifiers. In unnamed namespace, name of the namespace is not mentioned in the declaration of the namespace. The name of the namespace is uniquely generated by the compiler. The unnamed namespace you have created will only be accessible within the file you created. So it's one module deal. So here we have a program Now we create a namespace, and that's only have integer I in there. And then we set I equals 10. And this one is unnamed namespace. So this one, when we print, you print out 10. And that need to be the same file or unit. And you can use scope resolution, scope specifier, the scope resolution mark double column. So here you have the namespace first and second, and I can access I of the first or the second to set to different value and print out as 1. And then you can have then 2 different namespace, and you have one namespace first, and you use that, and you set it to 2, and you will print out 2. And you can have a namespace and with some number and class in there, and you can set the value for it and use the constructor. And actually you print out the namespace n2, and you got num1 and num2 from different namespace. You actually get 70 and 90. Different varieties using namespace. So here we have namespace 1 and 2, and then I set the two numbers 80, 90, 80, 50, and 50, and that actually belong to different namespace. And I create a student using the namespace 1. So we can have same class definition inside different namespace, and that means different class definition. This concludes chapter 8. Thank you. Bye now.